Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right. Well, we are here. It's been
Again,
2 weeks.
It has, because you keep traveling.
I do. Yep.
Yeah.
Last week I was out in the Bay Area for the Kotlin at Google Summit.
Ooh.
It was an internal conference for Kotlin, and it was awesome.
Did you learn a lot?
I actually did. Yeah. You would not believe how hard it is to make it so that in a debugger you can evaluate an expression, especially in Kotlin where the bytecode is not representative of the code always because of things like inlines. So anyways, turns out it's a hard problem, and I learned all about it.
Nice.
And I'm glad I do not work on compilers or debuggers.
Yeah, it's hard. Also, the Summer Tech Forum is now a developer retreat, which means, companies seem to be still reluctant to send people to places for conferences. So now there's no fee, and there's very little structure, but developer retreats, we get together and work on interesting things and go on hikes and mountain bike rides and that kind of thing. So, but it's very unplanned. So
this is August 10th through the 14th.
I thought it was 13 through 18, but okay. No, 5, 6, 7, 8. Yeah. But anyway, it's up on the summertechforum.com.
Okay.
So if you go there, you'll see it.
Join us in Crested Butte.
Maybe
we'll do a live episode with people who.
That's a good idea.
Who come up for it.
Yeah, that'd be fun. Yeah, that's a great idea.
Speaking of Crested Butte, we have a guest with us, Josh Suereth, longtime friend of mine, who you came up here for a Java Posse roundup. Was that right?
Or it was the first Tech Forum, maybe? Or like when it switched to Tech Forum?
Maybe it was the first Winter Tech Forum. That's what it was.
Okay.
Yeah.
It was great.
So you've been up here.
I had a good time. Yeah.
Well, thanks for joining us, Josh. So I used to work with Josh at TypeSafe, now Lightbend, and I'm going to forever say TypeSafe, now Lightbend.
Yeah.
Or maybe I should say Scalable Solutions, formerly known as TypeSafe.
Oh, they changed their name again?
They're on like the fourth name or something like that.
Wait, did they change the name? It's not Lightbend anymore?
No, it is. Yeah, it's still Lightbend.
Oh, okay. Yeah. Changing
a
company name is a really questionable move. It's like a CEO power move. I'm going to change everything. I'm going to change the name.
Yeah.
It usually doesn't work out that well.
I believe it was Scalable Solutions and then like ACA or something. And then they joined together. And that's when we became TypeSafe, which is what I will forever know it as, because it was TypeSafe the entire time I was there. And it became Lightbend shortly after I left. Yeah. I think you left before it became Lightbend, right, James?
Yeah, I did. Yeah.
James seems to have an uncanny ability to know when to move companies.
Yeah. So Josh, when we were at TypeSafe, we worked on build tooling stuff together, and that was a whole lot of fun. So Bruce and I have a lot of questions about build tools for you.
All right.
Why do build tools always suck? Like it seems like everyone always hates build tools, no matter what the tool is. Like, why is build tooling so hard?
Yeah, so this is a really important question, I would say. There's a lot of aspects of software in this category of this is something that I need to do to get my job done, but as a normal developer, I don't care about it. I just want it to work. I don't want to learn about it. I don't want it to get in my way. However, it's a really complicated environment sometimes. Like there's a lot of really intricate pieces of software in build tooling and a lot of hard problems depending on what the language solves for you and what is left open to you. So when it comes to build tools, right, the basic problem is I want to not even care about it. I just want to write code. And I want that code to build. I want it to be completely scalable. I want it optimized. I want it debuggable. And I don't want to think about it. Yeah. And then there are people in the world who actually love that kind of aspect of, how do I stamp this? How do I get, signatures on things? How do I make sure that it's verified? How do I control all the versions exactly? And that kind of junk that I'm using. And they love build tools. So what you do when you own a build tool or work on it is you try to address those two people, right? There's like, for the most part, anytime you make a feature, you're like, okay, if I'm someone who just doesn't give a crap at all about this build tool, what should this feature look like? Like, it should not be in the way. It should be dead simple. You should copy and paste it from Stack Overflow, that sort of thing, right? And if anytime you fail at doing that, you piss someone off and they hate you. And guess what? You're always going to fail.
Yeah. So you've been the recipient of a lot of SBT hate over the years. And yeah, it's like, it's so hard to please everyone because you're trying to please people with very different objectives and goals, the build engineers or the software, the developers who don't want to care about the build. You're trying to please both of them, and whatever you do, you can't please both generally, or it seems really hard to please both.
Yeah. That's we actually, a lot of the debates internally in SBT were like, what should the default project support that comes baked in? It was highly tuned for making open source libraries because the authors of SBT, when it first started, and like when I took over, the kind of direction, was still, we were making open source libraries. So the default build made that simple. That's not necessarily making it simple for someone who wants to deploy, a function on the cloud, or someone who wants to run an executable or make a cluster, right? So because of that, like, differential, now you have all of these different use cases you have to match. And to the extent you make that a one-line config change, people will love you. To the extent they have to do anything at all in a build file, they will hate you, right?
Yeah, I mean, I remember with SBT, when I first got into it, I'm like, oh my God, this is so complex and I don't understand anything. And I don't want to understand anything. I just want this thing to do what, I need it to do. And
because I'm excited about getting my program to work, and this is in the way.
Yeah, exactly. Right. Bruce and I were working on our book last night, and then also working on a build tool related project. But we spent more time in the build, working on the build, than we did actually writing code. And that's a frustrating experience for someone who just wants to write the code. So I feel like SBT, maybe coming from that world of some complexity around the model for the build, which is maybe unavoidable complexity, but we can talk about that in a minute. But coming from the place where it was created for library authors, as a user of SBT, that complexity was kind of right in my face quickly. And I think that SBT for years got a bunch of flack for that experience not being optimized for people like me. But then I want to hear about how, I think over a number of years, that really changed. And I think that SBT really got to the place where, for most users, it wasn't that painful. And users, I mean people that didn't want to be build maintainers.
Or did you just get more comfortable with SBT? You may have the curse of knowledge here.
It's true.
I think it's probably a little bit of both. James actually is a more advanced SBT user. I can say that with confidence, having seen things he's done in SBT. But I also have heard, like, the best compliment I ever got at a conference was someone came up to me and, hey, you know what? SBT is no longer the worst thing in the Scala ecosystem. Right?
And that's like, what you're aiming for with the build tool, is to not be the worst thing in the ecosystem.
Yeah, just not be last.
I mean, we aimed higher, but like, it was a sign that things were improving. And like, so to go to one of the things you said, when you first hit SBT, all the complexity was in your face. SBT was called Simple Build Tool, and the simple was actually about the complexity as you learn the tool. So if you've used, say, Maven or Gradle, I can slap together a Gradle build real quickly. As soon as I have to do something like make a custom task, I get slammed with a whole bunch of additional complexity. Now I want that task to cache things. I get slammed with a whole new set of complexity. Now I want it to interact with other plugins, a whole new set of, and it just compiles and compiles and compiles. So SPT was designed where the complexity of doing anything in it was the same. It's not about being simple. It's about like a same complexity. So if you learn how to do one thing, you can do anything in the tool. That's the original design. However, it's obvious that that's the wrong thing for a build tool, right? That might be the right thing for, say, a collection framework, maybe, possibly. But I still think that's not the right kind of attitude in general for software, for any domain. If you're providing an abstraction layer, you want to make sure that there's a component of it that is abstracting away that layer so people don't have to think about it. And so the fundamental tenet we had going into SPT when I started working on it was, okay, you need your first primary user is someone copy pasting things from Stack Overflow. You don't support that person. Like, this is a person who just wants to work on a project. Yeah. They're like, I just want to add a library dependency of this cool library I'm trying out. I don't need to understand how that flows into the deployment model. I don't need to understand like this like test : arrow whatever crap that is like added to library dependencies. Just tell me how to copy paste it. I'm going to be looking at some other example, and it better work, right? Yeah. If I can't copy paste and modify like a string, then we fail. And that absolutely
without having to understand the build life cycle.
Right.
Yes, exactly. You shouldn't have to understand how we cache things to add a library dependency, right? So
I think
that was like
really is a critical point. Is that is something that significantly changed SPT from the user side. Was the copy and paste ability did evolve over time, and I think when users like me were frustrated by SPT, it was because the copy and paste ability wasn't as good as it got later on.
Yeah, and I do want to credit.
I guess there's two sides to that. Like, one is the like build tooling side and the build definition side, but then the other side is having good answers on Stack Overflow and the documentation having what you need in it and that sort of thing.
Do you suppose Rust's tool might have been named for cargo culting? So you can just cargo cult your way into a build. Maybe that's why they called it that.
It is nice. Like, if you've used Cargo, your ability to get a project up and running almost instantaneously is right there. And Rust's attention to error messages is great. Like, it's I would argue their class of tooling in Rust is significantly good, and kind of a good model, I would say, for a lot of other ecosystems. With SPT, honestly, we had good Stack Overflow answers and people who would answer Stack Overflow. These are people who treated builds as software. They didn't think of it like, oh, I want to do my software. They thought of it like, oh, the build is my software, right? And they were answering things. The problem is you could copy paste it out of Stack Overflow and get some crazy error message that you didn't understand very easily.
Yeah.
And have no idea how to like unify this, right, in the old system. So I do want to credit Mark Herrick because I gave him this challenge of figure out copy paste, and he came up with those macros that we ended up using, where we had independent lines. Each line could be copied in, and each one was kind of a setting and kind of more declarative, and it just leaned into the declarative nature that SPT should have had to begin with. Because the original SPT was more, let's model a build as a class. And I have
it was like write your build as a Scala program, basically.
As a Scala program, but like with classes and inheritance as the way that you share config and things. Having seen that and having worked across a lot of different build tools, I still think that's fundamentally not a great model. It doesn't seem to fit well. When you run into the limitations of it, things fall apart hard.
Yeah, that's one of the things I wanted to go into, which is there's this spectrum of build tools. Ones that are fully declarative, ones that use general purpose languages. SPT uses essentially a general purpose language, but with a kind of higher level DSL on top of it. Gradle does the same thing with Groovy and with Kotlin, whereas Maven, no fully declarative, like no ability to program in it unless you want to build a plugin. And I've wondered. There's trade-offs to both of those. Like, the declarative model is easy for tooling, it's easier for copy and paste, But as soon as you hit the boundaries of what you can do declaratively, then it's you're into a whole nother world of programming and how you control the build. And then on the general purpose language side, you can do everything, but then that leads to a lot of upfront complexity, I think. So I don't know, how do you, like, is there a possible middle ground, or do you just kind of have to pick which you want to optimize for?
Yeah, because I have to say the DSLs in Gradle have not helped.
Part of that, I think, is that they were designed around Groovy and then ported to Kotlin. And I think if they started with just Kotlin, that they could have probably done a better job making rational.
I don't know. I also feel like the mindset of the design just, I don't know. It didn't fit in my head, that's for sure.
I feel that, but personally with Gradle, I think the rigor that they've added to their model over time has they've tried to keep some things backwards compatible, and some of the core decisions they made when they actually made breaking model changes to how the build actually functions. And so you get more and more of this cognitive dissonance on that API. You know, like, again, they added a really great caching layer around tasks and things that you have to opt in that DSL. And when you do so, it feels like a completely foreign object to the build, but it's actually core to how Gradle works, right? So it's just really weird. And I think partly that's because Gradle has such a long history, started much simpler, you know, and evolved. But I totally feel you there. I would say if you looked at Bazel, I'm personally not a huge fan of mono repositories, which we could get into later. Ironically, I work at Google. But anyway, if you look at Bazel, how they fragment between like creating new tasks and using existing kind of declarative syntax, they do a decent job of, here is an API that is Python that you can embed in our build file, but it actually kind of evaluates almost separately or independently of then the declarative syntax of, here are my dependencies. So there's a clear delineation between when one thing runs and when another to the developer. There's a well-documented kind of like Python scripting language in there that is decent. And then you have these really, really heavily declarative, like, I do this thing and only this thing. It takes away a lot of flexibility in terms of what you can do. But in practice, it's I think they know what they wanted to do and kind of nailed a developer experience around it. So if you can abide by the limitations imposed by their overall design, that one has, I think, the best split between how to do configuration and then how to do customization. You don't feel like you're in a completely different world. You feel like I'm just in the lower layer. You know what I mean? Like, okay, I can see how this layer and this layer fit now.
That's the ideal.
I understand this layer, and I can do anything I need.
Yeah, that's the ideal way to have abstractions, is that when you're working at the higher level abstraction, you don't even have to think about the lower level at all. You don't have to know that it exists. But as soon as you need it, you should be able to seamlessly drop down to it without having to totally revamp how you have thought about things or how you've done things. So that sounds like a better model than that kind of fits between the declarative and the general purpose. It's like, yeah, maybe we can have a model that's both. It reminds me actually of Flex, where one of the things I actually liked about Flex was that you had the declarative XML language, and as soon as you needed to drop beyond that and have more flexibility, you were in the imperative language, but the declarative language was really just a declarative layer on top of the imperative. And so you always knew the direct correlation between the two. And if declarative works, great, use it. If not, drop down to imperative. And I don't know, that transition always felt good, but yeah.
Well, have you ever heard the term paradox mapping?
No.
Because this is exactly one of those scenarios, right? It's if I want to be completely general purpose and super flexible, I expose these low level details in this imperative language that can do whatever the hell it wants. But then if I want this like declarative, dead simple to use language, and I have those two users, and they're literally at odds with each other, the more I focus on this one, I can do it at the detriment of this one. So what you do with that kind of a paradox is you look at, okay, what's the good of the left-hand side? What's the good of the right-hand side? What are my negatives? And then you go try to balance. And that's literally what you're doing. You're defining where the balance is for your tool. And you try to look at, okay, if I am too declarative, I am completely inflexible and I can't service use cases. So then you watch your bug reports on your build tool and you watch your user feedback. And if you see, I can't do this, how do I do this, how do I do this, like as a constant theme, you're like, okay, we're too declarative. We got to work on the imperative a little bit. Similarly, if you're on the imperative and people are like, like, this is annoying. How do I even set like one library dependency, which is where SBT kind of was, right? It was too flexible when it first came out and not declarative enough. You look for that and you try to map to the other side, but really you're bridging two at odds goals. And you can't do both at the same time, but you can find a balance in the middle. And you don't want to swing back and forth. Like, Maven was a huge swing from Ant, right? And Ant was like, you only get tasks. You can only like do little basic, implementation things. And it was, XML make. But done in a way that was really hard.
Ant and Flex both kind of went off the declarative rails in the same way. So it was probably Ant that was actually first in this. JellyScript. Do you remember JellyScript?
Oh, yes.
People with Ant were like, oh, the declarative is insufficient. So they created a XML declarative programming language, which, had logic structures and imperative programming in XML. And interestingly, my example of Flex did the same thing down the road because people were like, how do I do an if statement in my declarative language? Well, we don't have that. You have to drop down to the programming language. They're like, that's too hard. So then they added like if blocks and stuff in the XML. And I'm like, okay, at that point, like, I don't know, it's Getz's law, which Brian Getz has something along the lines of every declarative language slowly slides towards being a terrible general purpose language. And it's like, I think you have to really intentionally be like, no, here is what the declarative language is good for and good at. Let's not take it beyond that.
Yeah. Oh, I totally buy that. By the way, Jelly was the Maven 1.x plugins were written in Jelly. Yeah,
yep.
The XML.
Yeah. Jelly.
So Maven 2.0 was much better in that you could use a real language for your plugins instead of everything in XML. I still personally, and this might be a preference thing, I still think there's value in like a language which blends some declarative aspects with some executional aspects when it's done well. And you kind of see this in a lot of modern programming language design where there's a kind of a focus on constructors where I make, like in Rust, for example, I can allocate structures real simply, almost in a human readable, JSON-y view. And then I can blend in some imperative or like, logic later. But I have this aspect of my language that's just dedicated to config in a modern programming language for a general purpose. And that's because I think there's almost always a need for a declarative looking block of code, no matter where you are, if you're a build tool or not. Right? There's always that need. And I am a fan of languages that help make that simpler. I think Scala 3 versus Scala 2, some of the syntax changes they made actually make this a bit better. But interestingly, you see other languages like Dart, for example. Dart is a language that I have a love-hate relationship with. There are like a few ideas in there I think were phenomenal. And one of them was a mechanism of doing hierarchical allocation of classes that just turns into a more elegant looking thing, right?
Yeah.
And you really
Kotlin
feel
has
like
this
you're
with like
working
type safe
on
builders, or also called Lambda, or built on Lambda with receivers. And I heard a term pretty recently that I was surprised I hadn't heard before, but it was DSL. So we've talked about DSLs in programming for a long time, but EDSLs being the embedded DSLs, or the languages that have the ability to kind of embed a DSL within it.
I always thought those were just called internal DSLs versus
Maybe it
external
is the
DSLs,
same
but
thing.
that's fine.
Yeah.
Well,
Yeah.
now we have
I think
external and embedded, so they're both EDSL.
That doesn't work.
Yeah, that gets tricky. Well, XDSL. Yeah. So it is great that programming languages are embracing the idea of these EDSLs or whatever we want to call them, and so that we can get the declarative style structures within the programming language itself. And yeah, I think Kotlin's done a good job of that. Sounds like Rust has done a good job of that.
Well, I do have a question for both of you. If you've done, modern cloudy stuff, say Kubernetes, right? What do you think of YAML as an execution language?
God. So terrible. So terrible. That just totally gets his law, is that it's this terrible declarative language that it has so many foot guns, and then people try to build this general purpose language on top of it, and it just turns out to be such a horrible idea.
So here's something. I don't know what, how it's going to come out, but the next version of Python is going to include, I assume it's a library as part of the batteries included for TOML.
Oh yeah.
I don't know if that's
TOML support in Python. Yeah,
that's
TOML is a much better option than YAML.
What did you say?
Oh, that's a good example of what I was suggesting with kind of modern language design, having, embedded configuration components in your general purpose language. I love that that's coming. I mean, not that I'm a fan of TOML specifically. I love that these features are coming in the languages, because I think there's so much value to have those declarative aspects in your language. And then you can immediately then blend in your imperative. Again, if we talk about like a paradox map, right, between configuration and imperative, you need both. And my firm opinion is configuration is code, right? When I'm writing configuration, I'm changing the behavior of a program in a more limited fashion. When I am writing a program and I expose configuration parameters, I'm exposing a new programming language for like the person operating the binary to leverage. Right? They change the behavior. They script it. It's basically, I'm inventing possibly a really shitty programming language for them to leverage.
Yeah. Usually.
At least if I'm writing it. Yeah.
Well, and I guess back to SPT, I think this is something that SPT did well, is to give you that declarative language, but do it in a way where you can escape hatch very easily out to Scala itself. There's so many times in my builds where I'm like, oh, I just need an if block in here. And you can just throw it in and still do your declarations, like, mix your declarations with your imperative logic. And it, I don't know, it feels natural. You don't lose the copy and paste ability. I don't know. I think it's actually a pretty good model.
My experience, initial experience, was with Make, and Make was purely declarative. But then there became, I think it was GNU Make, and they started adding language components to solve that problem. And I kept coming along with them, and then I could see where they stood at the precipice, and they go, oh, we're trying to make a language here. Oh, we better stop.
Wow.
Yeah. Getz's law playing out again.
Yeah. Well, that's where like a good model of a build tool that didn't cross that boundary, and I think because of distribution things, is Bazel, right? Like their fundamental core model is Make. It is, I have files as inputs, I have files as outputs, and I have a thing I run to generate that. And that thing I run is a little Python script. That Python script can execute things, whatever. That's like the fundamental core model. And then you as a user don't interact necessarily at that model. You say, I have a project, here's what it is. When you declare dependencies, you declare dependencies that may be like meta, if you will, but under the hood, that meta dependency is still considered like a file, right? And it still generates stuff. So it's a very, very, very simple model with kind of like that escape hatch that I think worked well. And they kept their line. And the way that they solved it was to add a completely new mechanism that from a user standpoint, you feel like you're in the same build file, right? You feel like you're in the same build system, but you're not at all practically, right? The one runs completely different than the other, even though it feels the same. In SBT, I think the biggest mistake we made, the underlying setting system is a multi-dimensional kind of weird dependency matrix of Doom. It's a really cool paper from academia for how to do kind of inheritance across dimensions and you know, n-dimensional kind of theory configuration thing. And it was looked at as, okay, if we make this our fundamental model, we can do cool things like leverage the exact same definition for test in compile. From compile, sorry. The definition of compile can be used in test to compile your test code separately. And we don't have to rewrite that code. In practice, that model was conceptually very difficult for developers to understand. And even though we got the declarative aspect down, understanding, like, if I have a compile, or, you know, if I have like a compiler setting, right, of like, here are my compiler flags, I had this then n-dimensional space of compiler flags for testing, for compiling, for running, and that n-dimensional space was rather complicated and really confused.
Well, and there's
developers.
An inheritance like hierarchy to it as well, which
yes,
it's like multidimensional with inheritance or with some hierarchy underneath it as well. So
like
hard to wrap my head around.
It was a fundamental aspect of reuse of SBT, and it was something that we were never able to make it kind of either intuitive to everybody or simple to everybody. And I think that's where, when people still hate SBT, that's the thing I would point at as the most complex and hard to use thing. It was the most flexible thing from a development standpoint in terms of how we could accomplish a lot of things, but it also limited how it scaled too, right? Like it was both the success and the failure of SBT to be able to grow, you know, beyond where it is now. Was that specific system?
I don't think I've ever found deep inheritance hierarchies to be understandable. You know, I know it's like, oh, well, you just go to this level and you modify this thing, and it's like, it just becomes overwhelming so fast. I think that was one of the, this is why, you know, people are reacting now so much to object-oriented stuff. I think it was the inheritance hierarchies and
just at some level that hierarchy gets incomprehensible.
You can't hold all that code in your brain. Like if you're going to figure out what happens, you click on a method, it has one line and calls another method. Great. That's not where my bug is, but I have to remember that line when I click on the next one now. You know?
So we were also going to ask you why, I guess it was plugins.
Oh, before we get to plugins, I have an extension on this topic. So one thing that SBT has done really well is build debuggability. And I feel like part of the reason why it's able to be so good in SBT is because of a foundational model of, I don't know, immutable data structures or something. I don't know. Tell us about like how, like, what is it that makes build the debuggability in SBT good? Because I feel like it is actually really good.
Yeah. This is where you want to limit your model. So that, like I said, the setting system in SBT was its greatest success and its greatest weakness at the same time. In SBT, there is a kind of a runtime lookup of everything that's going on, but we didn't just model, say, tasks. Like we didn't model just this is a name of a task a user can type. We actually modeled all the way down to here's a setting the user has. And we kept the entire graph of, you know, this setting maps to this setting is used by this set of tasks. Because in SBT, when you define anything, you're defining an edge in the graph. You're defining here, set this value, to these things that I consume. And we limit the language that you're allowed to use. SBT does not use Scala, right? It is its own language that in some cases you can use Scala.
Huh.
Right? So when I say like, foo : equals bar, that colon equals isn't equals, right? You're not literally assigning a variable. You're assigning something else where we could instrument and actually track all the dependencies. One of my favorite things in SBT. So if you're familiar with flat map, but I don't want to get into like monadic things, but this is important for, say, executing tasks. If I have a test suite runner, right, and I want to pass that test suite runner a collection of tests to run, I could have a set of tasks that are defined as their own tasks in SBT's model, and then I could pass a collection of them to another thing and then run that collection. When I try to like create a task that uses another task, that is when observability dies in SBT. That is when I can no longer inspect the dependency chain, right? Because
this is the task dynamic piece, right? The dynamic task?
That's what task dynamic is in SBT. Yeah. It's where you can have a dynamic dependency on the graph that we aren't aware of, which allows you to do some advanced things. There is a way to encode task dynamic such that we retain full visibility. And what it means is, so how do I phrase this? In a general purpose language, right? I can define a function inline anywhere and then run it. So in SBT, I could actually define a function that does a task that does whatever the heck I want and run it inside of task dynamic. And everything that does is invisible to me. What we looked at doing, and this never made it in SBT because it was a bit too breaking, but would have fixed the observability problem, and we really negotiated this. You can actually require that subtask to have been defined somewhere else in an observable fashion with all of its things hooked up that you never really run. And then you can load it in and run it multiple times dynamically, as long as everything's pre-registered. So we went to all these weird hooks to make sure that effectively anytime you have a dependency that a task makes use of, it's tracked. That means you're not using normal Scala code, you're using macros. If you look at the syntax of SBT,
the instrument, and like the one of the values that lead to build debugability is that the build tool can fully understand the graph of how everything relates, right? And you need some way to do that, and Scala doesn't give it to you, at least by default, and so you use macros to add that on top.
Yeah, SBT actually has its own compiler where it extends the Scala compiler directly at the parser level to be able to parse things appropriately, and then turns them back into kind of a class file that it compiles. But fundamentally every line of an SBT build file becomes a Java class file where the dependencies are completely clear. Like a setting in SBT, I know every setting that needs to go into it, and I know the value that comes out of it. And that makes it easy to track. Basically, functional programming, if you think of it as pure functions, it's easy to instrument pure functions because your inputs and your outputs are well known. It's harder to do imperative, but imperative is still necessary.
Yeah.
But you have to enforce that at the model.
It's one of the reasons why the immutable model of SBT, why that fits is because you also need immutability to be able to have correct graph, analysis or tracking.
Well, yeah. Another way to say that is a setting is the shape of what will happen, but it doesn't actually execute anything. It's just it describes the edge. It doesn't do it until you actually run a task or something.
Yeah. So I guess I've used SBT long enough where I think I kind of understand the model of SBT and what's underneath it. Bruce and I have really struggled with Gradle because we feel like we just don't at all understand the foundational model for the build tool. And it feels like at what point when I'm working on my build would it be much easier if I actually understood the underlying model underneath it? And yeah, how quickly do you throw that in the face of the developers, the users? That's, I think, a hard question.
Yeah.
Well, and is the model simple enough where you can do that early and not have to worry too much about it? Whereas I do feel like generally, except for the piece of SBT you talked about, the hierarchical multidimensional piece of it, which is still complex and hard for me to grok. But except for that, I feel like I kind of understand the model of SBT, and I am not even close to there with Gradle.
I don't even know where to start.
Yeah,
and I've read books, and I've watched you throw Gradle files together in total mystification. I'm going, how does he know what to do? And I know you're just flinging things at it and saying, does it work? And oh, let's try this. I just like I need to understand what I'm doing. That's just me. You can just go, well, let's just throw paint at the canvas and we'll see what happens.
Yeah. So okay, so let's go on to plugins. So it feels like build tools. It seems like the problems they solve are simple, but it turns out there is a lot of challenges and complexity to what build tools are doing. One of those pieces that seems really complex is plugins. How, like, I don't know. How do you think, as a build tool creator, maintainer, how do you think about plugins and how they change the whole world of build tools?
Yeah, you can kind of see my philosophy on plugins with SBT auto plugins and how those work, but effectively there's an underlying model to a build tool with how to execute tasks. That's like a fundamental thing, right? Like there's a few tentative components of build tools of caching, tasking, and then setting basically. So where does my configuration live? How do I run tasks? And how do I make sure everything's cached? For plugins, though, if I want to plug into an existing build, I almost need another model. Like I need to know, here's what a Java build looks like, or here's what a Rust build looks like, because the way those tools work are subtly different. For Java, people tend to do these giant directories that turn into one jar, as opposed to like every directory is independent and isolated, right? So you need to make sure that when you have a plugin system that comes into a build, that plugin system can be aware of the general shape of the thing it's plugging into. So, which means you need a consistent view of, here is what a Java build looks like, here's what a Rust build looks like, here's what a C++ build looks like, here's what Python looks like for running tests and things. That is actually rather hard to do. And what like, say Maven, for example, had one build lifecycle thing where it's like, here's what every build has. It has this phase, this phase, this phase, this phase, and you attach into a phase. The problem with that is if I have interdependencies between tasks from plugins in that phase, I couldn't express it. It was an inexpressible thing. So you almost need,
the API is so limited in Maven that you can't always define what you need to define. You get lifecycle hooks or you get lifecycle callbacks basically, and you have no idea what order those things are going to be applied on a given lifecycle phase, right?
Right.
And if you need another phase, good luck. Too bad.
So what we started doing in SBT is we started fragmenting the build, the default build into auto plugins. So we had a plugin that was, I do dependency management in my build. And you have to treat that plugin as a freaking public API to every other plugin, right? Yeah. The dependency management part was, here's how I say, add this dependency from Maven, right? Was what that was for. And it was so that you could create on top of it, say, a Kotlin build or a Java build. In practice, everyone always creates a Java build and then like other language builds on top of it. But in any case, the actual language plugin of how do I build this language and that ecosystem is its own interface. It's another layer of the build that you have to treat as an API to your plugin authors, and you have to expose extension points. SBT, one of the other successes it has is I can literally take the Java compile task for a Java build, completely replace it with my own, leveraging the underlying one, and the user would never know.
Yeah.
Right? That's a thing I can do as a plugin. I can say, wait until after Java's done registering itself, then I'm going to run and replace what it did with my thing. Another language wants to do the same, they can, and we can layer in that way. So if I know I depend on, say, the Kotlin build, I can rely on Kotlin to have been installed and then override what it does and extend it. And that was a fundamental thing in SBT in the core model that was kind of added, that kind of allowed a very rich plugin ecosystem to survive because, two things. One, we kept our interfaces stable. If I have this set of settings and this set of tasks, that was an interface to plugins to leverage. And the second thing, and this is the dirty secret, is we had maybe 5 to 20 people in the world who could write SBT plugins well, and we were a tight-knit community, and so it was easy to kind of advertise and describe how things work and get these idioms out to them. And they created just a bajillion number of plugins that covered a huge amount of the ecosystem, and they worked well together. So, if you think about creating an API and having other people leverage it, right? And then they run into friction and they need to fix, because there weren't that many in this ecosystem, that could evolve rather quickly. If you have a larger ecosystem, that's going to be a little bit more difficult. There's going to be a bit more friction possibly between plugins. There's going to be a little more maybe less adaptation, but it's still, that's like a critical component of this is to make sure that, you can evolve that API. I'll give an example from IDEs. This is the same thing, right? If you wanted to build a Scala or Kotlin IDE that worked with Java in Eclipse, that has a very heavy plugin model, that's considered a really good plugin ecosystem, right? So Eclipse is considered one of the best plugin ecosystems in the world. But the Java development environment did not expose itself as a thing to be extended. And so if you were working in Eclipse as a plugin against Java, we literally used aspect-oriented programming to hack the crap out of it to add our extension points to give it an API. That's how you had to do it. And it's the same with a build tool. Like build tools and IDEs are I would argue they're basically the same thing, just in a different light. Anyway, you need to expose each of those components as an API for people to leverage and plan for it to be extended.
Yeah, and that's something that I found is challenging. Is I feel like in Gradle, the way that plugins interact with each other leads to this place where I have no idea what is going on in my build because two plugins are doing potentially conflicting things. And it seems like a really hard problem to solve, but I guess in some ways you're saying SBT solved it by making it so you have to expose an interface as a plugin author. And if you want to integrate with another plugin, then you do it through that interface. And
you actually declare a dependency on it, like it's a library.
Right. Yeah.
Gradle's semantic conventions. Have you seen these? Like the semantic convention route that Gradle's going?
Which is it?
So there's like an idiom in Gradle where you define a semantic convention, like a Gradle KTS file, where you say if you define your build as an application, add this plugin and do this thing. If you define it as Java, add this plugin and do this thing. That's like a first step to kind of getting, but it's the problem I have with it is it's an evolutionary step, not a revolutionary step. And I think Gradle might want to do a revolutionary step because their underlying fundamental concepts are pretty sound. But because they keep evolving, like that abstraction between what you see and what they want keeps diverging. But semantic conventions are the closest thing in Gradle to this world. So if you're using that idiom, right, you can say, I have a Java application in it or Java subproject. For that Java subproject, I'm going to add in Kotlin as an option to compile. Right, I'll add in that plugin only when it's labeled as Java. It doesn't have the same kind of dependency feel between tasks. You still get the same kind of friction because this is added on top of the plugin ecosystem, not before the plugin ecosystem.
Right.
But it's a step towards it.
Yeah, and then one of the other challenges with plugins, I think, is how that surfaces into the build DSL or build definition, because some way the then user has to be able to configure the plugin, and how that gets exposed to the user seems like something that is generally hard to get right. Yeah, and then I guess in the world of SBT, it 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 comes in through settings, right? And settings and tasks that get added into the build graph, and then you can then set those settings or call those tasks from your build, just like you would normally. So it's in some ways a pretty constrained model, I guess, in SBT for how the plugin then exposes itself to the build DSL. Does that sound accurate?
At one point in time in SBT, plugins were just settings that the user would automatically shovel themselves on the project.
Yeah.
With I think it was 13. This was one of the few things I actually did. And most people accredit a lot of things of SBT to me, but honestly, Mark Herron and Eugene did far more. But anyway, Eugene Dakota. But this is one of the things I actually designed was the plugin system, and that the fundamental concept is just like a bundle of settings is what a plugin is. It's a bundle of settings to apply, and it leverages existing settings and modifies them because of that underlying model that allows you to do that. So the only thing a plugin is allowed to do is say, okay, I need this set of settings, and here are my dependencies, and then that slots where your manipulations go to the build.
Yeah.
Right. And that's it. That's all the plugin is allowed to do now. And user settings always happen after plugins, so you can always override and fix things. And the key with that design was to make sure it is 100% clear where that setting goes. Right?
Yeah.
And that the magic of where the setting goes should never confuse the user. The user shouldn't have to know anything at all about the crazy dependency system we have to track the plugins, whether or not things are enabled, whether or not there's conflicts. That should all just be invisible to you, right?
Yeah.
But it should just feel natural and right, and just fit. And that was kind of the key of that.
Yeah.
That's not my experience with Gradle. I have a sort of a side question, which is because I feel like in recent years, Gradle's been trying to do more with running, parts of the build in parallel. It seems like they've been kind of inching their way towards it. And it seems to me like that's a fundamental architectural decision that you sort of want to do at the beginning, is to say, oh, yeah, we want to run. Does that sound right?
Yeah, absolutely. Like I think you saw Make add, multiple jobs to itself, and that, SBT, by default ran in parallel from the get go. Okay. That was like one of its big things, was to try to run in parallel.
And that was the build model and defining the graph and all the dependencies across the build. You can then figure out the parallelization points much more easily. Whereas, I think your model has to be built from the beginning to support that, right? And maybe that's why
there's subtleties
challenging
here,
to add on later.
Yeah, there's subtleties here. So since SBT did it by default, our users didn't do the things that Gradle users do. My favorite, when I write a unit test and I access a global resource in my unit test, I can no longer parallelize, right?
Yeah.
Like legitimately, their unit test will talk to a real database. In SBT, because of parallel tests, early on, we got a whole bunch of bug reports about, hey, my unit test randomly failed. Flaky. It's like, yes, they're parallelized. You can turn off the parallelization if you want, but stop touching global mutable state in tests. Because we would actually parallelize at the test level as well. and make sure that the unit test ran multi-threaded. That was another fun, possibly overzealous optimization of SPT, where it had its own test running frameworks in addition to the underlying test suites. Anyway, but that's anyway. We don't have to go into that, but it is a common failure scenario. Users need to understand the build is parallel. You can implement a task, a custom task, that cannot be parallelized so easily. It's very easy to do. So in SBT, it breaks. In Gradle, it doesn't, which means if they were to start parallelizing, a lot of tools would probably be broken.
Yeah, it seems like with programming languages, there's things that should really be in from the beginning, like, generics and
generics for sure. I've seen
nullability.
that screwed up.
There's and bolting some of these things on later is really hard. And yet, how do you start with something simple and evolve it when you need to upfront have covered a bunch of really complex things? And
I think that's why the cost of entry for a build tool is so high. Like all the complaints you saw with like SPT and how bad it is, you're only now seeing some major competitors to it, possibly, but it's still it's hard to oust it from the Scala ecosystem because the cost of entry is high. Like you're saying, there's these foundational components you have to be a good build tool. You have to have caching. You need plugins at this point, right? You need a good core model. Parallelization is part of caching.
Debuggability, parallelization, performance. So many different. Just the space is so complex, and to start
Can
from
I do
scratch,
a quick rant for you on that? Okay, so minimum viable program or minimal viable product has been, in my opinion, like the death of some good software, because people don't pay attention to V, right? They're like, oh, let's just keep reducing scope to the point where we can get this out there and we'll evolve it later. But there's a lot of scope they cut that actually is important to make it viable in the long run. And then you see that we feel this now, right? Because you didn't kind of focus on that, like what are my core tenets I have to nail before I release it.
This is why architecture is important.
Well, and the MVP of a build tool really is something that probably takes, I don't know, 5 engineering years or something to get to what is actually viable. Like the mill build tool from Li Hui, I think there's a lot of really good stuff in it, but he, at least last I checked, didn't have support for plugins. And so that's just one reason why I think mill hasn't caught on that much in the Scala ecosystem. Is it's just like that's one piece of MVP that is necessary and doesn't exist yet.
Yeah, and that's another thing. Like based on the discussion we just had around plugins, you heard a lot of that complexity and a lot of the crazy things SPT allowed to make plugins work well. Mill is a much simpler model, and the question now is, can it add plugins that work well?
Yeah.
With that
can
model?
It evolve to that, or does the model need to like have that from the beginning?
Is there anything you can do about the dog squealing?
My wife just walked outside and he's just super sad.
Oh,
hey, dog,
poor dog. What's your dog's name?
His name is Sky. So sorry about that. I didn't realize she was going to head out for lunch, but
that's fine.
Yeah, it's always important.
No, I think we've reached the limit of the sky with build tools
on the podcast. Yeah,
the sky is the limit.
Yeah. Yes.
No, it's really interesting to talk through the build tool stuff because there's so many tensions, and I think that finding the balance across all these tensions is really freaking hard, and it's and it takes many iterations probably to get it right, and I feel like SBT through the many how old is SBT now? 12 years? Like it's
oh man, it was 2006 or 7 maybe even maybe even
Yeah,
earlier.
so
But I feel like it was about 2006.
15 years ish old at this point, and now I feel like it's now it's pretty good. 15 years
Yeah,
later, it's pretty good with a
yeah. I
lot of
mean,
work, a lot of your evenings and weekends spent, and when you worked at TypeSafe, actual job time, but and many
yeah,
other people as well. Not just
Are
you.
there are there? It seems like there needs to be PhD programs that specialize in the problem of build tools because it's
Yeah.
that complex.
Yes, does seem like it.
I wonder if they exist.
Yeah.
there are
Well,
papers and things, but yeah, the some of the space they're exploring there is um, I don't know how to like. So there's a weight of users on real world tools where we get a tool adopted and it had a simplistic model, and now because of the users you can't change it. Whereas with the PhD research is like they don't have users, they're crazy out there. For us to go from like where we are today with Gradle, for example, to like research based things that we've seen, you'd either have to sacrifice the entire Gradle community for a Gradle 3.0 or something, or
yeah.
you evolve slowly and hope you can, take what you have today and get there.
Bring your
And I think
users
that's the
along
main
with you.
problem. Yeah,
Yeah.
yeah, and
Well, I
again,
think it seems
Go ahead.
like at some point you have to go, oh, we see all the things that didn't work about this, and we've learned, and now we need to create a new build tool that takes what we've learned and builds.
But then it's such a hard problem because you
Yeah.
got to bring old users to the new one. You have to bring the plugin ecosystem.
Well, it has to be dramatically better so people will go, oh, finally.
Yeah.
Well, let's use that. And I think the things that we've been talking about here could achieve that. But
Yeah, someday, Josh, I want to sit down with you over beers and talk about if you were to ever create a new build tool, what would be some of the design philosophy models of it? Because that would be fascinating to hear. What you do differently.
You'll first have
given
to
the
get me
opportunity.
to get back my young hubris of my earlier days as a developer.
See, I think this is
that's the
why
problem.
no one ever creates a second build tool.
Right.
Part of the problem is that you have all this wisdom of what would make a good build tool, and you're like, yeah, I'm never fucking doing that again.
Yeah.
I don't have the
You have-
energy for it
you have
anymore.
the crap beat out of you, and you just go, no, I don't have
You
the
know how hard
enthusiasm.
it is, and
Yeah.
you're like, nope, no thanks.
Mhm.
So the wisdom is
Yeah.
just wasted, Yeah, I mean, is there a person in the world that's created a second build tool? I don't think they exist.
Mhm. Yeah, although Nicholas Wirth created more than one programming language. So,
Yeah.
but I think most people these days, it's like if they create a programming language, they just have the one in them.
Yeah.
And then they
Well,
go, too
actually,
hard.
yeah, like Scala was Martin's like third or fourth language or something. But that's
Was
that I consider like your first big hit. Like you're like, okay, let me just, these were the ones that got me along the way, so I got my big one.
Yeah, when I say creating a second build tool, I'm saying you created a first one that was really successful,
Or that got used.
that actually got used, and then you created a second one. Because of course you could create a build tool or a programming language that never gets used, and then create another one. But yeah. All right. Well, Josh, thank you so much.
So we've solved the build tool problem now?
Yeah, I mean,
Solved.
We know everything we need to do.
Easy. Yeah.
Okay. Well, then there's nothing more to talk about.
That's right. Build tools solved. Time
Yeah.
to move on.
Yes, courtesy of Happy Path Programming.
That's right. Cool. Well, thank you so much, Josh. Appreciate your time.
Yeah, thank you for having me.